All right, so in the last exercise, exercise 20, we developed a data model for rainfall data, which consisted of a list of tuples. And each tuple, its first entry was a year, and its second entry was a list of rainfall totals for each month. Um, One of the things about that is that it was a nice data structure and that it was pretty, I'm flipping over to code from that exercise. It was pretty easy to create. We could just kind of append this nice tuple to a big long list, and everything was easy. But in creating it, but if we look at how we accessed it, it was sort of awkward. In particular, if we look at this is where I was printing out a particular month in a particular year. We had to index into the table at the right year. So first off, we had to make a transformation. If the user wanted 1996, I didn't want to go to index 1996. I needed to go to index 1996 minus 1896. Then I needed to say, well, I'm accessing the second element in that tuple, the months, um, and then finally the month. So it just kind of, it was awkward. It's not that simple. And there was a couple other scenarios, situations where that was playing out as well. The thing is we've now learned at this point in the course about dictionaries. And dictionary objects actually will allow us to create this data structure a little bit in a more easily accessible way. So what I want to do for this is create, instead of a list of lists or a list of tuples, which contain lists, I want to create a dictionary where the keys for the dictionary are the years, and the values are this list of monthly rainfall that we've already created. So we're actually going to be able to borrow a lot of this code, and I think it's useful to see how we can take existing code and adapt it now that we've learned a little bit more. So the overall data structure, this is how we started out, right? We have the list of tuples, right? And each tuple has a value for the year and then a list. Now we're going to have a dictionary. Okay. Remember those dictionaries, the literal values have the curly brace. And we're going to have the key values for each pair are a year, and the value will be a bunch of rainfall data. So 1.01, 2.1, and so on and so forth. So it's a little bit of a simplified data structure. Now they're not necessarily guaranteed to be in order, but it's sort of simple to draw it that way at least, and all the way down to 2014. So as opposed to that kind of convoluted list structure, we can see now that if we want to know anything about a particular year, we can directly access it. So if we want to know something about 1898, we can directly access it using the key value, and that'll give us the month, and we can index into this, right? So we can index right in. So if we call this table, now to find, April 1898, it's just table 1898, and that's not an index, right? It's not, we don't have to offset that or anything, it's just a key. That'll give us the year. That'll give us a list of months back as a value, and I can just access element 3 for April, fourth month starting at zeros. So that's much more convenient way of accessing. So worth our while to build a table like that rather than what we had before. So next question is, well, where do we start to change? Where do we start with this? We have already our build table function, and right now our load table function. Right now it's returning a list, and I'm going to want that to return a dictionary instead. So I'm going to convert that into a dictionary. We're not going to call append here. We have to actually construct a key value pair from each year. Now, if you think about it, our make year tuple function is really still working perfectly fine. It's breaking a long string of text out into individual tokens. The first token was the year. The last 12 tokens was rainfall, and it's returning that tuple. I can keep this function as is. I don't have to modify it. It's returning both pieces of data. The issue is that I'm not going to just take that tuple and append it to a list now. I'm actually going to create a new key value pair. So I'm going to say, the year record equals make year tuple. And now the first element in that tuple is the year, and the second element in that tuple is the list of monthly rainfall. So years, year record, 0, right? So there's the key value, that's the year, is going to be equal to year record 1. And that's really it. Close the file, print out the years. Let's make sure that that is actually the case. So I'm going to just print out this table first before I start accessing it, because clearly I'm going to have to start accessing this a little bit differently as well. Some parts will be easier, some parts will not be. Okay, so let's just print the table in its raw form, and I'm going to comment out the rest of the program temporarily because I don't want it to crash it and kind of make things look a little more complicated. All right, so we'll run that. Okay, so we get our dump of our print, and again, it's not the most pretty form of output, but let's just make sure it looks right. We've got our curly brace for the beginning of our dictionary, the key 1895, and then a list, right? Then 1896, and then a list. 1897, and it looks like it's printing it out virtually in order. All right, so we've got our data structure. So now let's revise how we actually access it. So the first thing that we need to look at is how do we figure out the first year and last year? We can no longer index this into 0, right? Or kind of take the first element in table or the last element in table, because we can't really guarantee the order of any of the keys here. So what we can do is use the minimum function and maximum function on a list, and the list that we need to use is the keys of the dictionary, right? And we can get that. We can just sort of say keys, which will give us all of the years in this dictionary. So it's pretty straightforward. Since we use the variable everywhere else, we don't really have to repeat ourselves. And now we've got min and max years. Looking through this, we're not really accessing the table, and now down here, over here, sorry, this is just accessing the month table. Over here, we're accessing the table, and we want to access it by year and month. And here's where we reap the benefits of our new data structure. It's going to simply be table at year. So we're looking up the list corresponding to a particular year, and then we're indexing in month minus 1. The average function is going to change. Nothing about this code is going to change, but the average function's got to work with this a little bit differently too. Let's just check and see how this works. For every y in table, that's going to be a little different now, because for every y in table is actually giving us every key in the table. So what we need is table at y, and we need the particular month we're looking for. Right? So every y in table is giving us an actual a key, right? And now we're indexing into our table using that key and finding that particular month. Everything else is exactly the same. So let's run this program again. Makes sense to run the test case that we used in the previous exercise, and lo and behold, we're getting the exact same answer. So it's from the user's perspective, nothing really has changed. But from a programming perspective, this is a little bit nicer data structure. It's a little bit more clear on how to actually access things. I think this makes a lot more sense just when you look at that in isolation. It's much more representative of a table.